with that 4x4 equation in an earlier case. And if you specialize, and you can probably do it a little bit faster. All right, so this is a one repeated factor, but L squared and Q. Whenever there's a Q irreducible factor, what is that special trick that I was talking about here? That is not specialization. That is not method of comparing the coefficient. The long division trick, right? So that's what we have. So I think I wrote it down here. The long division trick is this. There's L linear factor and Q quadratic factors involved, right? After doing this multiple times, I realized that if you write it like this, it's a fastest way. So this is not different. If you factor out L, you can see Q is L times something plus C. That's exactly long division. You just write the quotient one more time. If you write Q like that, it's a bit faster in terms of calculating this decomposition. So remember, not just writing down Q equals AL squared plus BL plus C. It is obtained by simple long division process. All right. That's also what I want you to pay attention. So here I do have this example, and I'm going to show you what I mean by that. All right, here's a problem. Right, you know what Q and L is, and here's a Q, and that's L squared. Okay, so let's do this one. So what is it that you should do? Q equals, right, x squared plus x plus 1 equals long division. How does it go? X minus 1, not x minus 1 squared, just a linear factor here, right? And is what is a quotient? Can you do the quotient? You have to match this x there. What should I put in here? X plus what coefficient such that it matches x? This is a positive 2, then negative x and positive 2x, that matches x there. So it's negative 2, so you should have positive 3 there, correct? If you do the long division, you get this one. Right. The key thing is that we don't stop it here. Is Q is there and L is there, but this is linear. You do it one more time. Here's x minus 1, that's our L. And what should I put in here to complete, make it equal to x plus 2? 3, is that correct? So it is the same as dividing x plus 2 by x minus 1. Quotient is 1, remainder is 3. So we wrote Q as L of L plus 3 plus 3. So it looks like L squared plus 3L plus 3, correct? Any question? All right. So now if you divide everything by L squared divided by Q, that's what this coefficient is, right? And so let's do that one here. First, L squared divided by Q, L squared divided by Q, everything works nicely. L squared Q. So that's 1 over L squared. That's good. What about here? L squared Q. That's very nice. It's 1 over Q. And how about this guy here? 3 divided by L and L squared Q. That's a little problem. LQ still leaves it there. So I forgot about that. So both cases you have to enter step by step, right? So I'm not doing L squared Q because I need LQ in the denominator. So I'm doing this LQ first. 3 divided by LQ. I'm not dividing everything by L squared Q, but LQ first. Then what it gives us is that 1 over L. This cancels. This is L over Q. Is this a good shape, L over Q? Is it decomposed shape, or do we need to do more about that one? Q quadratic, L linear. So this is a good term, right? You're not going to split that one or touch anything. So here's a 3 cancels, the 3 over L. So 3 over Q. And that's 3 over LQ. That tells us, that's the same as LQ we did earlier. That tells us how this 3 over LQ is splitted. All right? So we have that. It's 1 over L minus L plus 3. That's in the Q. What is L plus 3? L is there, x minus 1, 3 is x plus 2. So let me keep it that way. X plus 2 is 3 divided by LQ. Okay? So we know how 3 over LQ splits. So if you do one more time in here, this is the thing that we did it before, Q divided by L squared Q now. So L squared is already there. Here is the equation here. L squared divided by Q, 3L, L squared divided by Q, 3L squared divided by Q. This is what we want, pretty much, right? Except 3. And if this simplifies as follows, Q cancels, it's 1 over L squared, equals L squared cancels, 1 over Q. Now this one L cancel, but it leaves a 3 over LQ. But we calculated 3 over LQ there, and here's a 3 over L squared Q. And this is what we want. If this happened to be 4 divided by LQ, then you can easily change that 3 to 4 by dividing by everything by 3 and multiply back by 4. It's all constant. It's not going to change the shape of a decomposition shape. All right. So what do we do now? 3 over L squared Q is equal to, you subtract that in here, 1 over L squared minus 1 over Q minus 3 over LQ. But we have calculated 3 over LQ here, so we can replace that in here. 1 over L squared minus 1 over Q minus 3 over LQ is 1 over L. The minus distributed here, it becomes positive, x plus 2 divided by Q. This is all done now. 1 over L squared, and Q is the same, so it's a plus Q. X minus 2 minus 1 is x plus 1, and there's a minus 1 on 1 of L. You can see that this is fully decomposed form, correct? 3 over L squared Q is now fully decomposed like this. What we wanted was 1 over L squared Q. That's the problem. So what do we have to do now? Divide everything by 3. So it's 1 over L squared Q is equal to 1/3 goes up there. And I'm going to move it over here. Negative 1/3 goes up there. Plus 1/3 multiplied to x plus 1 Q. And that's the factorization. All right? That's the answer to the original problem. 1 over L squared Q. Right? But, is there any question? So you actually look at these two levels, and you can just put it together easily to get to here. So even though you're doing L squared Q, do LQ first, and then enter L squared. The equations are very similar. You just have to substitute a little bit. All right, if we're using the coefficient method, how is it going to decompose? We haven't actually done that in here. So let's work on, if you're using specialization and some other method than what we just did here, so it goes like this. X minus 1, because it's a repeated factor, x minus 1 squared appears. And that repeated factor appears alone here. Okay? I hope that's now straightforward enough. Okay? If it's a repeated factor, you have to repeat all that lower power in there, and you put irreducible factor x minus 1, always constant for the linear, over the quadratic, always this is cx plus d thing. So there are 4 coefficients, so you will end up at 4 by 4 equation, but you can still specialize at x equals 1, but because this does not have a 0, specialization is not that great, but you can still derivative. So you get 2 equations quickly out of specialization and derivative, and 2 more you're playing with whatever specialization you have to. X equals 0 and x equals -1, you can probably compute 2 more coefficients. All right? However you do it, that's fine. So that's 4 coefficient, not a big deal. I can still do coefficient and specialization, right? Right. So, but this is the one that I was talking about. L squared Q, we just did that. LQ squared, right? LQ squared, because this becomes nasty. So that technique we just did, it seems really helping. So let me go back here and save this one. October 14.4. Right. let's first set up. If you're doing non-tricky method, one of the two method, how does that factor? X minus 1 is not repeated, right? So this all by itself like that. Coefficient A, correct? How about, I'm going to just call that one Q factor, quadratic vector. So you have to go up to Q and Q squared. You have to go all the way up to that maximum power. And what do we have up here? Bx plus C, right? And here, dx plus E. So 1, 2, 3, 4, 5 was not 6 to 5. So you have to work out 5 by 5. So it's not very pleasant, right? So let's do that here. Q, x squared plus x plus 1 is L, x minus 1, and x plus 2 again, right? I think it's the same, it seems like the same equation, plus negative 2 is a positive 3. And that one is also written x minus 1 plus 3, so we enter Q equals L squared plus 3L plus 3 again. All right, that's the same exact thing. So let's enter L over Q, then Q over LQ, then L over Q, that is Q over L, and 3 over Q. L over Q cancels, plus 3 over LQ. So we use this equation for this 3 divided by LQ. Next level is that dividing everything by, to cancel, this is our target LQ squared, so you do LQ squared here. So L squared LQ squared plus 3 LQ squared and 3 LQ squared. And this is what we want, and this is canceled like this. 1 over LQ. Is that right? No. And this one is L over Q squared. This is good. It's a quadratic and linear numerator, so this is in good shape. And it's 3 over LQ squared. And 3 over LQ squared. This is what we want. This is in good shape, and that's in good shape. Only thing is in bad shape is 1 over L over Q, right? But what is 1 over L over Q? LQ? We just calculate it here, right? So here's a 3 over LQ is 1 over L. This what that one is, 1 over L over Q plus minus 3 over Q. That's what 3 over LQ is. What we want is 1 over LQ, so we divide everything by 3. So we finally enter here that one. Here, L over Q, everything is divided by 3. So it's 1 over 3L, L over 3Q, and 3 just gives you negative Q. That's what 1 over LQ is. And right-hand side is L over Q squared, 3 over Q squared, plus 3LQ squared. That's what we want. But everything else is in the perfect shape, right? It's L constant, Q linear, Q constant, Q linear, and Q constant. So everything is there. So it's a 3 over LQ squared is finally 1 over 3L minus L over 3Q minus 1 over Q minus L over Q squared plus minus 3 over Q squared. That's the decomposition. These two can be further simplified. They have the same denominator, and these two have also the same denominator. So here, one last bit is a 1 over 3L minus this is a 3Q together, but that doesn't have Q in there. There's a 3 have to be thrown in, so it's a negative L plus 3 because it doesn't have 3 in there, minus L plus 3 of Q squared. So that's the decomposition. Finally, 1/3 L minus what is L? L was x minus 1, so it's x plus 2, 3Q minus x plus 2 again, Q squared. That's only 3 divided by LQ squared, but the original problem is asking 1 divided by LQ squared, so you divide 3 one more time. So 1 over LQ squared. It's 1/9 L minus x plus 2. 1/9 Q there. 3Q squared x plus 2 is a full decomposition of this one rather than dealing with 5 by 5 and one specialization you're left, x equals 1. So if you actually do any of those standard 2 method, that's a pretty tough case. But if you use this one, a little bit better. Once you get used to it, it's actually very much better. But at the beginning, it just seems like too much juggling that I have to go through. But I hope this is correct. That's my comment. So in the later section of the exercise book, they have a bunch of examples of LQ squared, and I encourage you to use the method. All right. I'll see you on Friday.